All right, so today we're doing 13-2, solving the quadratic equations using the square root method. So when we have x squared equals 9, what would we do to solve this? Josh? We root both sides of the equation. So we can use the square root property of equality as long as we're doing it to both sides of the equation. Now the thing to remember here is you use this when you get the quadratic all alone. The reason being is once the quadratic is alone, the equation may tell you something more. So we want to get that quadratic. What is a quadratic, by the way? Yeah.
Anything with an exponent.
Not an exponent.
Two. A square?
A square. Anything that's squared, specifically. So, no, that's a cubic function. A quadratic function is anything that's squared. So when you have that squared term, that's what I mean by get the quadratic alone. Get the x squared alone. Once you get that x squared alone, we can use our square root property. Okay? So, we take the square root of x squared and the square root of 9. What's the square root of x squared? Kevin Park. Absolute value of x is equal to 3. And then how do I lose my absolute value? Neve.
Well, absolute value is negative or positive, so x is equal to negative or positive.
Perfect. And we have to account for that because, remember, we've got two, if I look up here at this part of the problem, I could square negative 3, and that would be a true statement, and I could square 3. So we're accounting for that negative value there. Okay? So we've done this before, but we're going to add a little bit to it. It's not going to be that much more difficult. Most times, not all times, you will have two answers with a quadratic. Okay, so let's do the next one together. What would I need to do? Jacob Vogel. We're going to root them, okay? And so we get?
Absolute value of x equals...
Not yet. Square root of... What would the next line read?
The square root of x squared is x.
Is equal to?
Is equal to the square root of 36.
Okay, and then what would I do from there?
You would root it means x equals 6.
Close. What are you leaving out?
Absolute value.
The absolute value. The next line will read?
Absolute value of x
Equals
equals 6.
6. Okay, now how do I lose my absolute value, Joel?
You would do x equals negative or positive.
We're doing x equals plus or minus 6. All right. Now you guys do number 2. Go. So what do we need to do to number 2? Step 1. Somebody I haven't heard from. How about Upperman? Shh. Okay, square root both sides. Then what? Good. And how do I lose that? What would the next line look like? And equals plus or minus 13. Okay? So, next one. I had a number of students say to me, well, we can't do this because 7's not a perfect square. But we're going to continue. We're going to do the same process. What would I do first, Ben?
You would square root both sides.
Square root both sides of the equation. And what would I get next?
You would get absolute value of y equals square root of 7.
Okay.
And then you'll get y equals plus or minus square,
So y equals plus or minus radical 7. So this is a perfectly good answer. And we keep it in radical form like this, reduced radical form. Mathematicians like it better in radical form than estimated. And it's not a word problem, so we don't need to really make sense of it. So we just keep it to plus or minus radical 7. Yes? Okay, questions on this? All right, so what would we do on number 4?
All right, we're going to want to get a variable alone, so we're going to
add 6 to both sides of the equation.
Add 6 to
get
both sides.
alone. So we
Okay,
get
we're gonna hold on. We're gonna get our quadratic alone. So I'm just reiterating what you're saying for the recording. Okay. So I add 6 to both sides. Keep going.
Okay, and m squared is equal to 13.
M squared equals 13.
We square both sides to get.
We don't square
or,
both
sorry,
sides.
we root both sides to get. And then our next line will read the quadratic of m squared equals the quadratic of 13.
Okay, we square.
No, we
Okay, so how's it gonna be?
m equal to square root of 13. I mean absolute value.
Let's start from the. What's the next line gonna read?
Radical m squared is equal to radical.
Perfect. And then what would I do?
And then we group the equation. So we get the absolute value of m is equal to radical 13.
And then to lose our absolute value,
We make the radical 13 positive and negative.
make the radical 13 positive or negative. So you get the idea? We can leave it in a radical form. All right, let's make it a little bit more difficult. Let's do this one more together. What would we do first, Ulysses?
We'll add 20 to both.
Add 20 to both sides. Okay, next step, Joshua Kim. Divide both sides by 3. And we're left with 16. Y squared equals 16. Next step, Josh.
Root both sides.
Root both sides, and we end up with,
The absolute value equals 4.
okay,
Y equals plus or minus 4.
and y equals plus or minus 4. Okay, you guys do the next one. Go. What would we do first? Give me one step, Devin.
We would add 16 to both sides of the equation.
Good. Adding both 16. And we are left with
We were left with 2x squared equals 20.
2x squared equals 20. Next step, Grant.
Divide 2 by both sides and we get x squared equals 10.
Good. Next step, Vogel.
You would root it,
Go on.
so you would get the absolute value of x equals radical 10.
Okay, wait, you're skipping steps. Square root of x squared is equal to 10. So now I want to see that step. You're using properties of equality. Okay, don't skip and do things in your head.
I did it.
You're doing a line of proof, and so that line of proof is needed. So what do I end up with next?
You get absolute value of x equals radical 10.
Good. Okay, next step. Jacob, finish it up.
Okay, so then it would be, to take away the absolute value, it would be x equals positive or negative radical 10.
Good. Okay, and that's our final answer. All right, so what would we do on this one? I got one for you, but I'm going to call you on a specific one. Dennis, what do I do first?
Subtract 30 on both sides.
You should be writing notes. And if you're just sitting there thinking and listening, you should all be writing notes. What are we doing?
Subtract 30 on both sides.
Subtracting 30 on both sides. Okay, next step, Zoe.
You divide 2 on both sides.
Dividing 2 on both sides. Keep going, Zoe.
You root it. You root both sides. And you get y, the absolute value of y equals,
Since it's a negative, can we take the square root of a negative? No. So at that point, that's where you say no solution. Okay? No solution. That's exactly right. We don't know what to do. That's exactly right. We don't know what to do with the negative, so we say no solution. All right, so let's try the next one together. Another exception that we're going to have here. Minky, what would actually, let me start with Adam. We're going to add 2 to both sides of the equation. And then I'm left with 2 equals 5x squared. What do I do next, Joel?
You divide 5 on both sides of the equation.
Okay. And so now we're left with what?
X squared equals 3 over 5.
Good. And now Minky. We root both sides. Did you hear what he said? No, I'm not asking you, Mink. Did you guys hear what he said? What did he say? Grant. So we need to rationalize that denominator. So how would I go about rationalizing it, RJ? Okay, we multiply by a fancy 1, which would be, and again, what I did here was I took the absolute value of x squared as x. I'm sorry, the square root of x squared is the absolute value of x. But here, earlier today, somebody wanted to multiply by radical 3 over 5. I'm multiplying by a fancy 1. And so what do we get here? What does that become? Yeah.
Radical 15 over 5.
So this becomes a radical 15 over 5 is equal to the absolute value of x. Okay, how do I finish that up? Kevin Park.
Instead of absolute value of x equals plus or minus the square root of radical 15 over 5.
Perfect. Okay, questions? All right, so that's one of our exceptions that we get. You can take a look at those. All right. This time my quadratic is a little bit different. What kind of quadratic do I have? What kind of quadratic do I have? All right, so let's look at this quadratic. What's different about this quadratic, this squared term? Grant?
It's in a parentheses, so you have to square 2 things.
Close. It is in a parenthesis. It has a special name. Benedict?
You have to FOIL it.
No, we don't have to FOIL it. Matthew?
It's a binomial.
It's a binomial, and the binomial is its own term. I don't need to FOIL it. It's not like I have 2 different ones. It's exactly the same. It's a perfect square, right? Because it's being squared. So we're going to do the same procedure. The quadratic is alone. There's no coefficient to that parenthesis, to that binomial. So what do we do to get the quadratic alone? To get this, Kevin Park? We root it. We root both sides. And when you take the square root of a square, what do we get? Kevin?
Y plus 1 equals 1? Or no, the absolute value?
The absolute value of y plus 1 is equal to 4. Because the square root of 16 is 4. You should be writing this. This problem you should be writing. Okay. Next step. Actually, I want you to take a look at what I'm going to do, because in Chapter 9 we split the equation here. I want you to do what I'm doing here, the way my PowerPoint shows it, because when we get to the quadratic formula, you're going to get used to seeing it this way. So to lose the absolute value, what do I have to do? Yes?
You have to make the 4 plus minus.
Plus or minus. Set it equal to plus or minus. Y plus 1 equals positive 4 or negative 4. And yeah.
You're going to subtract 1.
Now we subtract 1 from both sides of the equation.
You'll get y equals negative 1 plus minus 4.
Y equals, now this is 2 equations. The negative 1 goes first. And that means negative 1 plus the 4 and negative 1 minus the 4. Does that make sense? Negative 1 plus the 4 and negative 1 minus the 4. So now I branch it. That means negative 1 plus 4 and negative 1 minus 4. And what are my two solutions, Josh Kim? 3 and negative 5. And there are my two solutions. Okay, Zoe P. What would I do first?
First, you have to root both of them.
We're going to root both sides.
So you said x minus 3 squared.
The square root of x.
Of x minus 3 squared equals 25.
Okay. And what would I end up with, Susan? Next line.
You get the absolute value of x minus 3 equals 5.
Good. Okay. How do I lose my absolute value? How do I lose that absolute value? Someone I haven't heard from. How about Plattner?
You have to make it x minus 3 equals plus or minus 5.
X minus 3 equals plus or minus 5. And then what do I do next? Someone I haven't heard from. How about Emily? Add 3 to both sides. What's the next line going to look like, Emily?
X equals 3 plus or minus 5.
Good. And so my solutions are, let's go with Aaron.
3 plus 5 minus 5.
Right, which 3 plus 5 is?
3 plus 5 is 8.
And okay. And negative 2. Good. Okay, questions? We're good with the binomials? All right, let's do some word problems. I hear the big sigh, but I promise you it will be much easier this time because we've already done it. No, this is easy. It's going to be easy. And I promise you, you've had background with it. It's much easier this time. Okay, so remember, with height of a falling object, with these kind of problems, I know you think this is difficult, but they give you everything you need. They give you the formula. You don't have to memorize the formula ever. All you have to do is substitute in numbers and solve it. Okay, so they're giving us this formula. So h is our height of the object. And I like to say this is like our ending height. H is like our ending height. So if you want to put that, maybe that's a better definition. That's the end. Okay. We have a T. What does that stand for? What does T stand for? Stacy? Time. Okay. And what is my C? Does anybody remember what the C stands for? Joshua? Josh?
How big? It's either how big the object.
No, forget that. Forget that. I totally mistaught that. Don't.
Then it's where, like, the height you drop the object.
The initial height you drop it from. Okay? So our C is the point where we're dropping it. Okay? Now, sometimes they're going to move these variables around. They might use other variables. Like if you remember the CST question, they use some other variables there. But it's the same type of problem. Now, let's look at the word problem. What are they having us do? RJ.
Find out the number of seconds it took to hit the ground.
Okay, so number 1, it wants to know how much time. That's our unknown. Okay, my time is what's unknown. Number 2 is going to be, okay, but what's happening? What's the situation like here? What's happening in this word problem? What am I doing? Yeah.
Dropping a penny from the top of the Empire State.
So I'm just dropping a penny straight down. That's it. Just dropping a penny straight down. Okay? So they're going to give us the equation. And we have to identify out of the word problem the different pieces that they give us. So what do they give me? Let's go with Dennis.
The height,
They give me the h. What's the h?
448 meters.
Does that go for the h or the c? What does that mean? What did I say the h stood for? Zoe.
The height that it's dropped at, the initial height, so where you started. The C.
Okay, we said there's an h, a c, and a t. What do these stand for? Wait, what did you say? What is the h?
I said the H is the ending height, the C is the
End height. Okay, this is the initial. Okay, so what's the number for the end height? What's the number for that end height? Yes.
0.
It's going to be 0. What's the number for the initial drop height? Josh Plattner.
448.
That's 448. And do we know the time? We don't know it. We'll call it X, whatever. It's unknown. Okay? So now we just substitute. The next step is just substitution. Okay? Okay, how would we go about solving this? We have two methods at this point that I've taught you. RJ.
Well, I guess since we don't have a linear term there, I would subtract 448 from both sides.
Okay, what else? Why else would I not factor? We've got two methods. The factoring method where we use the zero product property, and today we're doing the square root method. But why else would we not factor this? RJ?
It's a negative 5. I guess.
Not necessarily because it's negative. Stacy?
Plus 4 to 48.
There's no common factor in those two terms. So now's the time that I'm going to use my square root method. Okay, so he said we're going to subtract 448 from both sides and get that quadratic term all by itself. Yes.
Wouldn't you just add 5t squared so you wouldn't need to deal with the negatives?
It doesn't matter. If we were factoring it, Neve, you're right. I might move it to everything to the other side, but we're not factoring it because there's no common factor between 5t squared and 448. Okay? What he's saying is you could have done it that way too. Okay? So now what would we do? How about Christian?
We divide -5 on both sides of the equation.
Divide both sides by -5, and we get t squared equals 89.6. Now, because this has application, we want a number. We don't want a radical for our answer. Because we want to apply this. They want to know how long does it take that penny to drop. So 89 is pretty close to 90. If I'm doing the square root property, the square root of 90 is between what perfect squares? 81 and 100. The square root of 81 is? Square root of 100. Can we estimate it? Is it 9.5? About 9.5. Okay? So with these kind of word problems, you do want to estimate it out. If you're just solving a mathematical problem, we'd probably leave it in radical form. Okay? Now, the second type of problem is when we throw an object upward. We said when we're throwing the object that's dropped, it's the same thing. I would say the h is your ending height. But remember, we're just going straight down. Okay? When we throw it upward, we're adding one more element to it. Velocity. It's like your speed. Okay? It's going to be in, so your velocity is going to be like your feet per second, or miles per minute. Okay, so now we've got our initial drop height. Here's what's happening. Look at the initial drop height of my hand. Is that at 0? No, it's probably about 4 feet up. In this case, it'd be 4 feet up. And then I'm pushing it at a certain speed, and it makes that parabola. Does that make sense? Okay, but my ending height is what? 0. Right. Okay, so now let's look at how long will it take the ball thrown upwards at 10 meters per second to stay in the air if it's thrown from a 40-foot cliff. So I'm on a mountain. I'm now on a mountain. I'm standing on the mountain at the 40 feet of the mountain. 40 meters, sorry. I'm throwing it up, and then it's coming down and making that parabola. Okay, and they give us the equation. At your level in Algebra 1, they give you the equation. So let's identify what's given here. What are they giving us? What's the information in the word problem? I don't want to pull up the PowerPoint. Grant.
Initial height and ending height.
Okay, what's the initial height?
40 feet.
Okay, so our C will be 40. What's my ending height?
10 meters.
Be careful.
No, a 0.
0, because how long will it stay in the air? When it hits the ground, it's no longer in the air. And the ground is what height? Right, correct, 0. And what would that 10 meters per second be?
10 meters, so it would be 4 seconds.
Well, no, what is the 10 meters per second? What am I plugging that in for? What is that called? Dennis,
Velocity.
that's our velocity. Okay, so we've got our C is 40, our velocity is 10 meters per second, and we know that our H is going to end up at 0. Okay, and we just substitute in. Okay, now what would I do? Stacy. Now, I could factor it and put it off to the side and keep it in the parentheses. Or what about if I just divide all terms by -5? Then I get this. Now, am I going to factor this, or am I going to use the square root principle? Factor, I do X marks the spot. Look at my answers. What is the best answer here? What is it? Why is it not -2? Time can't be negative. All right. Make sure you have the homework written down. All right, so another student asked, well, how did we get that? Remember, we're going to factor this. So, like I said, we can factor. Remember when we used to, you can factor like this, divide out a -5, and we're left with t squared. Take out the GCF. T squared plus, actually it's going to be a minus 2t minus 40. But then we're stuck with that -5 there, and it's not really doing much. So instead of just factoring out the GCF, we're going to divide all terms. This is another way we can factor. And so we're going to divide all terms by -5. And when I do that, both sides of the equation, I get -5t squared divided by -5 is a t squared. 10 t divided by -5 is -2t, and 40 divided by -5 is -8. Now that's something we can factor. Now at this point you have two methods to solve. You can use your square root method or your factoring method. Since this is easily factored, we're going to use our x marks the spot, what multiplies to -8 and adds to -2. That would be -4 and +2. And so we factor the square root of t squared is t. And I have +2 minus 4 equals 0. And so the time would either be -2 or t plus 2 equals 0. the t would either be -2 or t will equal 4. But because this is time, time can't be negative. So our answer is it will take 4 seconds for it until it will hit the ground. It will stay in the air for 4 seconds. So that is the end of 13-2.